Morning, everyone. I'm Aaron Gergel. I'm the co-founder and CIO at Watchdog Cyber. I want to welcome you to today's webinar on cybersecurity and manufacturing. Today, we're tackling the pressing issue of escalating cyber attacks with a focus on cyber-informed engineering. Our guest speaker, Rees Machtemes, Director of Industrial Security at Waterfall Security Solutions, brings over 15 years of expertise to IT and OT systems. Rees will discuss the real-world consequences of cyber attacks on manufacturing operations and unveil the transformative potential of cyber-informed engineering. We'll further explore engineering-grade solutions to mitigate cyber risks effectively. If you have any questions throughout the webinar, please use the Q&A section and we'll get to them at the end of the presentation. From here, I'd like to extend a warm welcome to Rees, and we'll get things rolling.
Thanks for the fantastic introduction, Aaron. I'm happy to be here. I welcome you all to this great webinar, and I hope that it informs and entertains you all. Manufacturing is near and dear to my heart. As an electrical engineer, I've spent many years working in production, in automation and control systems, and having the opportunity to speak about cybersecurity and how we can secure these operations to ensure that they're resilient and can continue running and operating safely in the face of cyber attack is a very rewarding career for me. And I hope to pass on as much knowledge as I've learned in this field to you all. As you know, manufacturing is the heart of our economy in North America, and operations tend to be highly integrated. That means many network connections, many new technologies are being brought in to help increase production efficiency, business efficiencies, and to basically just create more value for customers and shareholders. But threats are growing to our operations, and so we must be prepared for this. There's an old saying that there is no fear when there is preparation, and this is what I hope to leave with you as a core message in today's presentation. So let's dive right in. So one of the things that we do at Waterfall, the company I work for, is we publish an annual threat report. And this annual threat report is for our customers, and it focuses on cyber attacks with physical consequences to industrial and critical infrastructures. So what does that mean? Think about, for manufacturing, anything that is process or discrete manufacturing, where you're taking either raw ingredients and producing a finished product or material, or taking discrete components and assembling them into a larger whole. So examples of this would be something like producing steel or aluminum products from raw materials, or perhaps taking individual discrete parts and assembling them into an automobile. These are the kind of things that that we track, and we look only for things that are in the public record, and only for things that that you can go to in the public record and verify for yourself. We want it to be the most credible report out there on OT cybersecurity and incidents that target these industries. And after crunching all the numbers, doing all the hard work of looking at thousands of incidents and finding the ones that are public and have physical consequences, what we have found here is what you see in the graph here on the top right of the slide. Since 2019, we have seen incidents to physical operations go from almost nothing to a very serious problem. And they're growing exponentially. If you crunch the numbers, you can apply a compound annual growth factor style formula that you often see in finance, but also in microbiology and virology, and in cybersecurity, we see a 1.92 times factor. That's the calculation that we end up with. Basically, these incidents are doubling annually since we've started tracking these incidents. And so the threat environment has changed forever in OT and ICS cybersecurity. It has changed from basically 1 or 2 incidents per year, almost nothing, a noise floor, to a very serious problem. And practically speaking, does anybody believe we're going to be going back to a year like 2018 where we had 1 incident? that with physical consequences that targeted industries like manufacturing. It just doesn't seem like that's going to happen anymore. And another thing I want to leave you that's a big takeaway from our 2024 threat report is that nation state grade ransomware, which is a serious problem for manufacturing, is becoming a serious threat. So whereas we saw criminal ransomware, where criminal groups were looking to encrypt systems, lock up systems, and then leverage companies and extract money out of them, the situation has slightly changed now, where we're seeing a larger component where there are nation state attacks, and nation state groups and ransomware groups are trading tools, tactics, and procedures. So the malware that a ransomware group might have used last year is now being picked up by nation state groups and used against targets, and vice versa. So nation state tools and techniques are getting purchased and used by ransomware groups in order to carry out ransomware attacks against operations, both in the private and in the public space, government and industry. So the big takeaway here is what we see nation states do to each other today, we should expect ransomware to do to all of us with money. We used to say soon. Now it's the reality. It's happening right now. And if you want to know more about our threat report, you can sign up. It will be published in only a few weeks. It's already been sent out to a graphic designer. It's going to get put on our website. You can sign up, and as soon as it's ready, you'll get an email. You can go here to this QR code here in the bottom right corner of the slide, or go to this link here, https://waterfall-security.com/2024-threat-report, and sign up for a copy. We do have last year's threat report available as well, but why bother? A week or two from now, you'll get an email with a new threat report in your inbox. Something that I wanted to do for you all here is to do what nobody else has seen yet and give you a sneak peek of what's going to be in the 2024 threat report. And what I've done is I've taken things specific to manufacturing for you all to share with you today. So thank you for joining this webinar. You guys get a bit of a treat for showing up. So some of the takeaways in the 2024 threat report. One of the biggest takeaways was that manufacturing was disproportionately affected. They saw the most number of incidents that all of them caused shutdowns, by the way, and impacts on production lines and to manufacturers. This was global, by the way, but most of these incidents occurred in North America. It was the worst year that we've seen so far, where 54% of incidents were all criminal ransomware except one. The one that wasn't ransomware was a supply chain attack. And if you look here at our pie chart, discrete manufacturing, assembling small parts into a big whole, that's the way we classify it, was a large piece of the pie, and the rest of it was process manufacturing, slightly less impacted in process manufacturing, but still a big deal. How was manufacturing shut down? So one of the big questions we had from last year's threat report, if you've ever seen it before, we did not track how things were shut down. We simply said that they were shut down and what the impact was. This year, we've made a big effort based on feedback from people in cybersecurity and OT cybersecurity to go and rate all the incidents and figure out, if we know from the public record what happened, why did they shut down? And the results were not a huge surprise to me, because I've heard a lot of anecdotes from customers over the years, but they were surprising in that they basically reinforced ideas that have been around for quite a while in the OT cybersecurity space in terms of how you go about protecting. What the results said was that the vast majority of shutdowns occur indirectly. So the OT and ICS network is indirectly shut down in a cyber attack. So what is happening here is that you get the IT network hit by ransomware, almost predominantly. Every incident is ransomware. And because of that, you have to shut down operations. Why? Well, companies have reported in the vast majority of cases, 63% of cases, when we know about them, it's an abundance of caution shutdown. They had to shut down because they were concerned that perhaps they could not meet safety requirements, or that Perhaps there's many reasons why you would shut down in an abundance of caution. It could be that you were told to. A forensic team comes in and says, we need to take an image. Everything has to be paused while we do that. Law enforcement might recommend it. There are many reasons, but ultimately they were not able to continue running independently their OT and ICS cybersecurity stuff because of these abundance of caution shutdown. The other major reason why this occurs is 25% of them report there's an IT dependency. So a cyber attack impacts an IT system on their IT business network. And because that's a shared resource with their OT and ICS processes, they're not able to continue running. A great example of that would be any kind of database, especially anything to do with authentication. So struggling to remember the term here. A Windows DA server would be a great example, or Active Directory server, sorry, AD server would be a great example of that. Shuts down on the IT network, which also shuts down your OT network because you share that resource. And then there's all kinds of other minor ways. Third party, where you have a third party that is connected into your IT or OT network, which you depend on. This is basically the other major reason why there is a shutdown. Threat actor profiles. Again, we are seeing a big change away from predominantly ransomware. When I say big, what is big? Well, this year we saw 80% of all incidents were ransomware globally. And we're now starting to see a year over year 5% gain in hacktivist attacks. Those are not yet impacting manufacturing, but if they're happening to everybody else in the industry, it's only a matter of time where it comes for manufacturing too. All right, so what does this tell us, especially for manufacturing? Well, what it tells us is if all shutdowns are due to ransomware, and the vast majority of them are indirect shutdowns where you must shut down out of abundance of caution or through IT dependencies, we can dramatically improve our cyber defenses by eliminating these abundance of caution and IT dependency shutdowns. And this is where we can have an interesting conversation on how to prevent this from happening. How can we change what we do to prevent this from happening and prevent these physical impacts? And so that brings us to cyber-informed engineering. So what is cyber-informed engineering? Let me give you an analogy. So if you have a physical process like a steam boiler, and this is the kind of thing that workers are around all the time in a plant environment. If your life depends on a boiler not exploding, if, we all want to go home to our kids at the end of the night, if you're working on a shift and you have an environment where you're working around steam boilers and one were to explode, none of us would be going home tonight and our plant would be shut down for a very long time. So in this particular situation, would you prefer a longer password on your PLC, or would you like a mechanical failsafe, perhaps one or possibly several redundant steam spring-loaded valves that would allow the steam to escape if the pressure reached a certain threshold? I would absolutely prefer the latter. I'm sure you would too. And so this is an example of cybersecurity engineering. What other mitigations can we think of that might allow us to operate safely and continue operating even in the face of a cyber attack? And so this is something, this way of thinking is not a new way of thinking, but what's new is bringing the cybersecurity element into it. And the engineering profession has been managing risks like this to public and worker safety for centuries. Think back to, steam locomotives. We've been managing physical risk for centuries. What's new about cyber-informed engineering is the idea that we need to now teach cybersecurity to engineers and also have engineers incorporate cybersecurity into their designs. And this came out of the Department of Energy. Idaho National Labs has published the CIE implementation guide late last year in September. I highly recommend you go and find and download it. You can just Google it, and it's a great read. The big takeaway here is that engineering grade solutions are deterministic and mitigate unacceptable consequences. So I shouldn't have to educate you all on manufacturing, but some of the unacceptable consequences in manufacturing that come to mind would be safety, especially for plant personnel, production outages, that would be unacceptable for a lot of manufacturers. Any damage to expensive long lead time equipment and tooling that would, cost you a tremendous amount of money and time to replace if it were to be damaged. And it's rare, but it's possible that a malicious cyber attacker might insert or tamper with your operational network and insert defects into the process, which would then cause product quality impacts, which would be a great concern. So these are the kind of things that CIE brings to the table. So enough about CIE. Let's jump back a little bit and look at a typical manufacturing network. Typical manufacturing networks look a little bit like this. This is a typical one where you might have a flat network. You have a plant environment, an assembly plant filled with, perhaps CNC machinery that is going to be building something on an assembly line. You've got a ton of HMIs. You've got PLCs controlling them all. And at the very high level, you'll probably have an MES, a manufacturing execution system. This is the kind of plant environment that's very typical. I say it's a flat network because inside the plant environment, you typically do not have any more segmentation or firewalls. You might, but this is most typical. And then you're going to protect that with a firewall in the middle here of the diagram. And then you're going to have your enterprise, your IT or your business network. That is where you would have your databases, your front offices outside the plant, any computers that you need, perhaps even engineers next to the plant that will be doing design and feeding it back into the plant environment, and then a corporate firewall on the internet. And, it's the 21st century now, vendor clouds, vendor solutions coming in that are integrated into this whole through cloud solutions are available. That would also include AI solutions and remote support and remote screen view or screen control is quite typical. So you might even have mobile devices. In this case, we're showing a mobile device that goes directly through wireless into the plant environment that would allow you to connect to HMIs and have remote screen control and screen view. So this is a typical setup. So the problem with this is it's quite easy for a cyber attacker to find a way in and cause a lot of problems. Typical vectors would be through the vendor cloud solution. If you compromise the cloud solution, even if it's VPN'd or encrypted, and get inside that cloud system, this is a target that is quite ripe for cyber attackers because they can impact hundreds, if not thousands of victims in one shot if they can breach a vendor cloud solution provider. And so this is becoming an increasing problem. We've seen this with the SolarWinds Orion attack that happened in 2020. And late last year, there was a couple cloud-seeded ransomware attacks like this through something like the MoveIt file transfer vulnerability, where thousands of victims were impacted at once. Other examples of this, of vectors of attack where an attacker can get into a manufacturing network is directly through the firewall. How would they do that? Steal the credentials to remotely connect and get in. They might find remote vulnerabilities that allow them to execute malware directly on the firewall and penetrate into the network. Other vectors of attack would be through the mobile endpoint here, which you notice is connected through a wireless access point directly to an HMI. This, it doesn't always have to be that way. You could have a VPN solution, but that would be similar to the cloud vector, where if you're able to breach that connection, you get into the network. And these are the main vectors that this network can be attacked. So this is the case for cyber-informed engineering. How can we do network engineering? How can we redesign this system to reduce the risk of cyber attack and prevent people from getting into our operational network, which runs our plant and keeps all the shareholders happy? So to answer that question, we have to think about criticality boundaries. What is a criticality boundary? Well, the operational network has certain risks that need to be mitigated in order to fulfill our design criteria. Design criteria, for example, would be to keep it continuously operating in a safe manner. So this boundary between your enterprise, your IT, and your internet environment and your plant environment is very different. The risks to your operations are very significant. If something were to go wrong and you were to suffer a cyber attack, the outcome in that particular network is much more significant than in a network like in your enterprise network, where the consequences of compromise would be a loss of data, a loss of IT assets, whereas in an operational environment, the criticality is much more serious. We call this a criticality boundary. And so worst case consequences are going to define the criticality here at the boundary. Think about it this way. What if somebody were to cause every CPU to be compromised and issue exactly the wrong instructions into the physical process? CPUs are quite amazing in some ways. They have incredible computational power, and yet they're very dumb in the sense that they will happily execute any instruction you provide to them. This is the way software and computers work. And so this means that we have to think about these criticality boundaries in order to design a better system. And so at this criticality boundary, there's this need, you have to prevent the propagation of these pervasive nation state and ransomware attacks that are now targeting everybody with money. Now, there are many, many different ways to protect at this criticality boundary. Ultimately, what you want to do is try and prevent malicious code and malicious instructions from entering into our critical network. So there's some ways that we can do this. One way is with analog signaling. If you have information that needs to be sent from your manufacturing environment, from your OT environment to your IT environment, you could do it all with analog signaling. And this would be something like your, 5 to 20 milliamp loop communications in between PLCs. There's just no way to send instructional information into an operational network through an analog signaling environment, especially if you're sending information out and you have a source and a sink of analog information. This is a common way, for example, you can connect a turbine in a power plant out to a third-party vendor. Now, that's not what we do in manufacturing typically, but this is commonly used. You have a small amount of information like rotational information or temperature information you can transmit out. This is a safe way to do so. Other ways to do that is in EPRI IIoT method. In short, this is also used in the power industry, but I just want to explain that the example here is that imagine you have a whole bunch of IIoT devices out in the field. You have all these sensors out in the field, devices out in the field, and you want to connect them all out to the internet. That is fine as long as you do an engineering study and you convince yourselves that there is absolutely no way to send control information into your critical network. So as long as they are sending information and gathering information only from your operational network and sending only abstracted data out, this is a safe thing to do. But you have to be absolutely sure that those devices cannot be compromised, do not have a CPU, and cannot be taken over by an attacker. And so that begs the question, that's nice. I don't know if that's really going to help me for our manufacturing network, which is highly integrated and has a lot more information going through it, especially out to cloud service providers or joining multiple manufacturing plants together, or just simply HMI data. What am I going to do with this? That's not useful to me. I agree. So probably not applicable. So one of the things I'd like to introduce to you today is the most widely deployed solution that I know of, which are called unidirectional gateways. And what they do is they allow visibility into OT networks without any risk of compromise. So let's talk about that right now. Oh, and by the way, if these kind of concepts are interesting to you and cyber-informed engineering is an interesting concept to you, you want to learn more about this, there's this really fantastic book that was written by Andrew Ginter called Engineering Grade OT Security. You can actually go and request a copy. I believe free copies are still available through our website at waterfall-security.com/engineering-grade-OT-security. It's also available from Amazon.com as an ebook. The only thing is that those cannot be given away for free because of the way Amazon is structured. So I believe there's a minimal fee for that, but you can get an electronic copy as well. And I highly recommend it. It talks about all these concepts in much greater detail than I have time to do today. So what is unidirectional security gateway? Well, unidirectional security gateways are specifically designed to be deployed at criticality boundaries that we were just talking about. How do they work? Well, they're typically a rack mount device that gets installed in your facility. And they're a combination of hardware and software. This is key. NIST defines a unidirectional gateway as a combination of hardware and software. The hardware transmits information only in one direction. So what that means practically is that you have a fiber optic laser on one side of the device, and you have a photocell receiver on the other with a connection, a fiber optic connection between the two. You have only one half of a bidirectional communications link. It's unidirectional. It sends information only in one way in hardware, guaranteed. And then the software component makes copies of servers and copies of information. This is not a firewall. Firewalls are routers with filters that can drop packets, that can inspect packets. It's not like that at all. So it's very important to think about this as a device that sends information in only one way, and then we're going to make copies of servers and systems. And what this allows us to do is completely prevent any remote attacker or remote connection coming into our protected network. So they're deployed to the criticality boundary. You have an industrial OT environment on left on the diagram in orange here, where you have your control systems and your servers, which are completely protected from remote attack because information only flows in one way. Now, I'm sure you're thinking in the back of your head, how is this even possible, Rees? How do you do a TCP/IP three-way handshake with only a one-way connection? Well, that's the magic of the software connectors. So I'm going to jump ahead a little bit here, but effectively, what a unidirectional gateway includes is any software connector under the sun that you can imagine that has ready-to-roll connectors that will copy data and protocols that you require for your physical operations and replicate them on the other side of the gateway. So some of the things that you might recognize here perhaps are things like Rockwell Factory Talk Historian, OSI Pi, anything OSI soft we can do, any GEI Historian, and Bentley Nevada, these kind of industrial protocols, all these data points can be replicated in the outside of the gateway. This way you have a copy of the information that can be looked at by your business network for business efficiencies, and it cannot be tampered with in your critical network, in your operational network. By the way, IT protocols are supported too. So if you need to move files across the gateway, there are solutions for that too. Anything under the sun. So what does it look like under the hood? If you pull off the cover, a proper unidirectional gateway should be engineered so that there's a steel plate dividing it down the center, and you have two completely separated modules. You should be able to convince yourself that information only flows in one direction from the left-hand side in the diagram to the right-hand side in a unidirectional way. So in this box here, you're going to see the compute modules, which are going to be running your software connectors, which are, also independent computers that are standalone, and dual redundant power supplies. This is an engineered industrial device designed for operational networks and industrial control systems, specifically engineered to be unidirectional and deterministic. It will do precisely what you expect it to because it's engineered that way. All right, let's move ahead here, a couple slides. So now let's look at an example where we deploy a unidirectional gateway. Same manufacturing network, gone unidirectional. What's changed here is we've removed only one firewall. And actually removing it would be optional, but most people would deploy it in this way, where you remove the firewall at the IT and OT boundary, the criticality boundary. You're going to replace it with a unidirectional gateway. And now all those HMI protocols, let's pick on Pi today, anything that's Pi can be completely replicated in your enterprise network. You have an exact real-time replica copy of it. And there's no latency or delay because, again, this is not a router. We're not forwarding packets. We're not inspecting anything. We're simply copying data across in real time and making sure that it's identical to the copy inside the OT network. What is better about this solution? Effectively, any remote attacker that's trying to come in through a cloud endpoint, trying to breach a firewall where there is no firewall anymore, if they're trying to come in through a mobile remote screen view or remote access, they simply cannot do so anymore. It's one way. So you're going to say to me, Rees, that's all fine and great. we have a more complicated situation than that. What if we have a more complicated situation? This is just simply not going to work for us. We can't deploy this because one of the most frequent reasons that the simple case here, where deploying unidirectional gateway will not work, especially in a situation like manufacturing, is because you often have other requirements. And one of those other requirements could be something like integrating a third-party supplier. In a just-in-time manufacturing case, you may have a business need to connect a third party into your operational environment. And the best example I can think of would be something like automotive manufacturing, where you have a third party supplier supplying your production line with parts in real time. And when they run out, they're going to be automatically ordered. And it's also, again, the 21st century. People don't order cars at the dealership anymore as much as they used to. They want to go custom order their latest build straight from the company's website. And so this order will end up into your production system effectively. And there's going to be a build sheet slapped on this automobile when it enters the production line as a frame. And it's going to get customized in real time. And you need to make sure the parts are arriving by the minute. And by the way, the parts might not arrive from across the street. They might come from out of country. They might come across the border from Canada. They could come from Mexico. They could come from literally anywhere. How are we going to integrate this kind of system when we're only allowed to send information out with our unidirectional gateway? Well, don't worry, I got you covered. So part of the reason why we do cyber-informed engineering is we need to think about the design process. How do we make it secure? How do we achieve zero production downtime and keep our systems safe? This is a tricky situation. This is one way that you could do it. There are other ways. And the way that I'm proposing here is that you're going to have your IT business network like we had before, you have your internet like we have before, and you have your operational technology, your operational environment like we had before. But what's new here is we're adding the third-party supplier, and we're going to use a typical DMZ approach where we have a DMZ and they're going to be connected into our business enterprise network in this particular example. And here comes all the parts orders in real time and information sharing. And what this means now is we effectively have three classes of networks. We have our safety critical network, our most critical network, our operational environment. We have the second most important reliability critical network, which is from our third-party supplier. Without them, we can't reliably produce our end product. And thirdly, we have the business environment, which runs the website, might do some accounting and might have some engineers sitting at workstations managing the whole business, including the C-suite and the executives sitting out in the corner offices. That's our IT business. And we're going to break these down in three criticality levels. The safety critical network is the one where worst consequences are completely unacceptable. We're going to design the system so that worst case consequences will be prevented to a very high degree. And reliability critical is where it is unacceptable that we would take downtime for our third-party supplier, okay, but it's not exactly safety critical. So there's a distinction there. And business is where you buy insurance, where the worst cases of worst consequences of a cyber attack could be absorbed. Yes, it will cost you some money. Yes, you're going to have to bring in a response team, but we can do this, and we know how to do this. We've been doing this for a while. So how are we going to protect this type of system? With our reliability critical network, we're going to connect them through a very, very strong firewall, a next-gen firewall. We're going to deploy intrusion detection systems, sophisticated cybersecurity protection measures, which the IT industry is quite typically used to deploying for important networks. And for our safety critical network, we're going to use the unidirectional gateway from the example we had before. So in this case, it is completely protected from remote attack. And our IT business is going to be protected with typical cybersecurity protection that we have for any IT department or company. And imagine that you've got these parts coming down the production line. They get a build sheet slapped on the front. We can do this. It's okay. It's acceptable to have information going in only one direction. As parts are consumed, as things are being built in real time, information and status is being sent out to the business network. We gather that information. It goes into our business databases and processes and software. And it does not mean that they are a weak link. If they were to be attacked in the IT network, you can still have independent communication paths going to your reliability critical network. This is the one that you protect with the next most authority and significance. And you're going to be continuously sending your third-party supplier all the information they need so that they can deliver parts in real time to the plant and have it all assembled into a whole. Now we have a great system that can continue running reliably and is very resilient to cyber attack. If a ransomware event were to happen on the IT network, that would be bad news, but we can deal with this. And we can set up communication channels from our unidirectional gateway to a reliability critical network and keep them happy with information. But because we've deployed very strong cybersecurity and spent our dollars smartly in that area, we can be sure that the infection will not spread to our third-party partner, and they won't be impacted by this, because the last thing we want is not to be able to continue production because our third-party supplier is either part of the risk or has been impacted by this event. We're getting near the end of the presentation here. Some other things I wanted to mention that form the part of cyber informed engineering are other ways we can look at abstractions for safety. So we've talked a little bit about unidirectional gateways, how they send information in only one way. Of course, they protect you against a remote connection exploit or attack. But there is always the need to get information into a protected environment like your operational network. So a more advanced topic is that there are other configurations possible here. So if you need to get antivirus signatures, production orders that perhaps happen on a periodic basis, there's an example here from the power grid, forget that. But the point is that there's always the need to get information back into the system. We can handle that. There are various ways we can do so. One reason for manufacturers that getting information into the system is becoming very important to them is because they're wanting to leverage AI and cloud solutions to improve their manufacturing efficiencies and processes. There are unidirectional products and technologies that can help you with this. For example, there's a technology called the flip, which is as if it picks up the unidirectional gateway, the laser and the photocell, and flips it around temporarily, sets it back down, and allows you to send information into the protected network for a short amount of time. Typically, they're on a timer. They have fail safes, so they will pick up and reset themselves and be back unidirectional in the direction outwards from the protected network after a period of time. This is a great way to send software updates or production orders into protected network. And the key here is you do it on your terms, not the attacker's terms. You control when and how long that flip occurs for. And so it's very hard for an attacker to deal with that. You can also simply disable it if you're worried. That's one possible way that you can get information into the system. Another way is with a temporary bypass. So there is technology available that allows you to temporarily completely bypass a unidirectional gateway with a conventional bidirectional communication system like any network card. This is a powerful way, again, where let's say you have a need to bring in a third-party solutions provider to help you with something on your OT network. You could temporarily bypass this. Typically, it's literally you put a key into this box in your operational environment and turn it. You've got a physical authorization here where you're bypassing this thing. And again, it will reset on a schedule if you like. It's configurable because you don't want to leave that thing bypassed permanently. Other things we can talk about here are when you're designing your automation and your control system network, there are ways that you can do this that minimize risk. And if you're sending information in or out into a protected network, one of the things that's important is how you send your information. a mistake would be to send a tremendous amount of information and make a tremendous amount of connections out to external systems and networks and the cloud. The reason is because every connection you make and every data point that you configure out of your protected network presents a risk. And the more of those connections and data points that you have, the greater the risk is that one of them, if they were to be compromised, would impact your critical network. So one example would be, don't just send everything you've got out of your network. It sounds obvious, but it's so easy to do now because we have powerful computers, powerful PLCs, and we have just unlimited processing power at our fingertips. We forget that minimizing your connections and your data points can go a long way to improving your safety. And when you're sending values and information in or out of your protected network, don't just send raw values and raw data. Think carefully about how you send that information. So, for example, if you're going to be sending temperature information, or better yet, a control set point into a protected network, when you design that data point, don't send something like a variable range between minus 300 and plus 999. Send a set point that would have a human readable and easy to parse value so that if somebody were to see this on an HMI display or see a raw number shown on a control panel, or even happen to be looking at the raw protocol data as it's going across the network, it would be easy for any human or machine to process. So if the safe state for this particular temperature set point is, let's say, between 200 and 500 degrees, scale that to be between 0 and 1. So anything between 0 and 1 is a good value. And anything outside of that range, anything below 0 or above 1 would be an unsafe state. Somebody can very quickly visually pick up and know, uh-oh, something's wrong. I know that anything above 1 or below 0 is bad news. What went wrong? So it sounds trivial, but this can make a big difference when you're trying to figure out, is something going awry with the process? Are we suffering a cyber attack or a design problem in our control systems? And so this is kind of the concept here. As much as possible, you want to make unsafe conditions impossible to specify or impossible to produce. And if you do see that, immediately you can throw an error and stop that unsafe state. Before we go to Q&A, I just wanted to quickly mention a little bit about ourselves. Waterfall Security was founded in 2007, over 15 years ago. We have offices around the world. We have deployments at thousands of sites in every key industrial sector, including manufacturing, power, oil and gas, and rails especially. We have a lot of deployments in. We're known as world leaders in OT cybersecurity, and our specialty is in unidirectional protection. So last slide I want to leave you with today. Again, if you're interested in more in the threat report, and by the way, in the appendices of the threat report is every single incident that we have used as a basis for our research. You can go and find all the manufacturing incidents. You can find the circumstances and why we've included them, including financial impacts. So please go and sign up, use the QR code, or go to waterfall-security.com/2024-threat-report and sign up for your copy. How much OT security is enough? This is really up to your organization to do a risk assessment and decide. This becomes a very tricky thing to do. But ultimately, what we want to do is figure out what is important to our organization. If we take all the worst cases of compromise and itemize them, which ones can we absorb and which ones can we not absorb? And I hope you would agree that outcomes like impacts to safety or continuous operations would be most desirable to avoid. The threat environment is changing. Unfortunately, it's not getting better, it's getting worse. Think about how you can deploy strong protection at criticality boundaries, and think about your networks in different ways, which ones are the most critical and which ones are the least critical, and protect them differently depending on the type of network. Another thing I wanted to mention is sometimes we have people that come up to us and say, why would we remove existing cybersecurity? Why would we throw out the firewalls? Really want to make it clear here that we're not doing that. You still need uh, strong cybersecurity protection in your OT cybersecurity network. If you have firewalls deployed there, especially next-gen firewalls, if you have intrusion detection systems and advanced cybersecurity protection that will be looking at the OT network and trying to decide if there's malicious activity going on, this is still important. Again, unidirectional protection protects against remote exploit and remote cyber attacks. Malicious insider attacks are still stopped by conventional cybersecurity protection. Okay, and so you don't throw the baby out with the bathwater, as the bad expression goes. You need both working together. IT working together with modern OT cybersecurity protection. And that's all I have for you today.
Great. Rees, thanks for sharing everything today. Q&A is open. So if there is anybody that has any questions, feel free to ask, and we will do our best to answer them. All right, so it looks like we do have a couple. We've got one that says, "What sizes of organizations did you study in the threat report? And are you seeing SMB businesses being targeted at higher levels?"
That's a good question, Aaron. We did not restrict our study to organizational size. Anytime we saw a public report of any industrial infrastructure going down, we focused mainly on industries like manufacturing and other ones you saw on the pie chart. We counted it if there was a physical impact. Physical impacts would be a shutdown, even if it was only for a few hours. We did not cover any kind of ransomware attack that would have had only a financial impact. Going back to this slide here. The bottom line is we took any organization. Now, most of the ones that we saw were probably mid to large size businesses, especially in manufacturing. I didn't see a lot of small businesses, but that's hard to define. What is a small business in manufacturing? I'm not sure if manufacturing really has a lot of tiny businesses. However, what I will say is that every organization has to protect their risk differently. And it really depends on individual circumstances to a high degree. Many manufacturing operations have been hit, and the threat actors seem to be going after any easy targets where they feel like there's enough money to make it worth their time. What appears to be happening is that criminal ransomware groups effectively have more than enough to pick from when it comes to victims, unfortunately. And they probably wake up in the morning like you and I do, and they grab their coffee and they've got a list of to-do items, and they're going to be going through all the basically victims that have been identified, and they're going to go just like you and I do every day, and they're going to go on LinkedIn, and they're going to go on Google, and they're going to do some searching and do their research. They're going to figure out how much money you have, and they're going to go after the people where they feel like there's a reasonable chance of having success. And unfortunately, even if you are a small or medium-sized manufacturer, if they feel like your cybersecurity protection is weak, and they could easily blackmail you either over your data or your physical operations, they're going to do so. And so I'm really not sure if it really matters what size a business would be. It has more to do with how much you have to lose. And I would venture that probably mid-sized businesses would be easily impacted. Small, perhaps they'd ignore you. Maybe you're too small to worry about. There's not enough millions there for them to go after. But At the same time, if medium and large-sized businesses improve their cybersecurity posture and small businesses are left behind because they don't have the resources to go implement a strong cybersecurity program, things might shift where ransomware groups are going to get more desperate and go after the small businesses. So we don't know that yet. There's so much that's possible that might happen in the future, but these are possibilities that you have to keep in mind. I think everybody can be a victim here. And one of the things I forgot to mention is the US, Canada, and Germany are the top 3 most impacted in our entire report year after year since 2019. And why do I think so? I think it's because these 3 countries have a very strong manufacturing base, and this is part of the problem. So I think anybody and everybody can become a victim. Um, it's possible.
Yeah, I agree with that very much. I think you know, threat actors are as lazy as everybody else, right? They want to look for that easy target, the easy money. So if they come across somebody that has a good posture, the likelihood of them moving on and finding somebody that has, a terrible posture is a lot higher, right? Um, the other question that came in is, when should a business start to explore this type of technology?
When should you consider, sorry, Aaron?
When should a business start exploring unidirectional gateways?
I see it as a new tool in the toolbox that some people have not heard of before. Um, my I work for a company that makes this kind of technology. We're not the only one out there. But what I will say is that it surprises me how I do meet quite a few people that have never heard of this before. I would like you to think of it as another tool in the toolbox that can help you engineer networks differently um, than some of the other tools that are available out there. One of the things that I think is very powerful about this kind of technology is that it's preventative. It by design prevents certain outcomes from ever happening. It's very deterministic. And personally, when you look at the cost of cybersecurity programs, I personally don't believe it's that expensive. In fact, it might be, depending on your personal situation at your personal organization, actually quite efficient in terms of being able to take a whole category of attacks off the table um, for about the same money as many other conventional cybersecurity solutions. So I would start looking into it now and not wait, and look at your particular circumstances and see, would this fit well, and would this be an easy win in order to dramatically improve your cybersecurity posture for not a lot of money. This is my personal feeling. Uh, of course, I'm biased, but consider that the firewall was invented, only about 25 to 30 years ago. And at the time, it was a completely brand new invention that changed the cybersecurity landscape. So unidirectional technology is another one like that. It's another tool in the toolbox that everybody should be aware of. And don't wait. Um, Definitely don't wait. The cyber attacks are not slowing down. And um, there seems to be a concerted effort by not only criminal ransomware groups, but other very bad guys, whether it's politically motivated or nation states that are kind of hell bent on either getting even politically or simply wanting to take all your money. Why let them take it away? Just doesn't make sense.
All right. That looks like that is all the questions for now. Do you have any other closing thoughts, Reese?
I just want to thank everybody for the opportunity to speak to you all. Again, as I said, manufacturing is near and dear to my heart. And I hope there was something in here that was helpful to you all. I appreciate any feedback that you have. So don't hesitate to reach out on LinkedIn. If you have any more questions for me, I just like making connections, and I really hope to make it out east very soon. I will be in Montreal for ManuSec. If any of you will be there, I will be there too with Jordan. We'll have a booth, Waterfall writ large. Please come say hello. And I hope to stay in touch with you all.
Awesome. Yeah, I want to take a moment and thank everybody that attended as well. If you're interested in this type of technology, feel free to reach out to either myself or Dan. We can definitely get you some more information. We'd be more than happy to do a risk assessment on your environment to help you understand where you stand today and things that you can do to get you in a better place. That's it for now, and we will see you all very soon.
Thanks, Rees. Thanks, everybody. See you guys.
Thanks, Dan. Thanks, Aaron. Thank you.
Yep.
Thanks. Bye.